Hello and welcome everyone. This is Civil Pro, and today we're going to do a structural design blog in which we're going to design this particular building in Etabs. So it's going to be a little bit long video. As you can see, this building is a G+3 buildings. We'll have many secondary walls also, and we'll also have a shear wall in this lid portion also. So this is going to be a long video. It's not purely a tutorial. It's kind of a blog. So let's move forward and try to complete the design. So open the tabs here and let's go. All the Indian codes are selected. Here we want to do obviously the custom grades and do the grades accordingly. In here, so we are seeing the spacing of the grids in this direction is around 4 meters, and only in between we have a 5.25, so it's at the wall centers basically. So we can do this, and this is 2.1, 2.1 and 7.85. so we'll do this grids this way only. So let's go. This is in X and this is in Y. So Y we have 3 grids, I think. So we delete one. So the first is 0, and then let's have only one drawing open so that I can minimize them. This entire thing doesn't worry. Okay, so done. And okay, so now in this we have 2.1. let's see, this is 2.1, first one. Okay, so 0, and then now we have 2.1 for the second grid. Okay, so it starts from the bottom, so we know that this kind coordinate starts from the bottom. So if this is start from the bottom, so this is 0, then there is 2.1, and then the next grid will be at this point, which will be 9.95. so 9.95, we do need another grid here, and this will be is equals to 9.95 plus 2.1, so let's see 12.05. You can also verify from this. Okay, select this, and let's go ahead and verify this. So this is also 12.05. You can see this coordinates along the Y grid in Etabs system. Okay, now let's go for the X grid here, and in the X grid we'll just go ahead, and here first of all we have 4 meters for one. Let's see, this is the 4 meter spacing for the first so we'll just do here 4, and then we'll do 8, and then we'll do 16, then we'll add more. Okay, the next one after 16 is 8, 6, okay, 8 of 10, 12, I think. Yeah, this messed up basic maths. 12, and then 16, and then 20. Let's go to 20. Okay, so up to 20 it is done. And then now we have the next grid, which is 5.2. it will be 25.25. so this will add another grid, 25.25, and click on add. Then we'll go here, and this will be 29.25, and then click on add, then select this. It will be actually 4 meters each, adding 33.25. so yeah, then we'll have 37.25, Then we'll have another one of 4 meter. It will be 41.25. 41.25, and then click on we'll click on add again. Okay, let's just take the length here. This will be 46.5. the next length 46.5. yes, and then click on add again, and then the next one will be there are two actually. So here it will be 50.5, and then it will be 54.5. so we got here just have to change this 50.5 and 54. Oh sorry, this will be 50.5 and this will be 54.5. Let me just check here. Last three coordinates 54.5, and then we have 50.5, and then we have 46.5. so 46.5, 50.5, 54.5. so that's the coordinates here of the primary things here. Secondary beams we can model later in the model itself. So we'll go with this thing and then click on OK, and then we want to edit the story data according to the elevation which we have got. Let's see the elevation here. 0.45 is the height of the plinth level, and then we got 4.2, 3.6, 3.6 and 3.6 and 3 meter for our mumty or our headroom. Okay, so basically let's take a base as a minus. So if we take the foundation depth included here, let's take the foundation depth as 2 meters, so and the plinth height as 0.45. so let's take this as 0.45 minus 2.45, and the elevation for this will be 0. No, not just messed up, sorry. This is the base. Base is at 0 here, and elevation for this is at 3. so height of this one, this particular story, you can see this story is 4.2. so if we give this height as 4.2, then this elevation becomes 4.2. but this, if you consider this as a plinth level, let's just change the name, plinth level. Okay, so this height will be foundation depth plus our plinth height. So let's take this as 0, not this height. This height, if I want to take this height as 0, no, I think yeah, I got it. So we should take this height, if you want to go 2.45, I should take this height as 2.45. okay, plinth level, and then I want to take this as minus 2.45, then it will be 0. okay, so you see what I did there. I wanted to take the plinth level at 0 and base at minus 2.45. so prefer to take the plinth level at 0 because of some reasons which we'll discuss later maybe. So 2.45 is the height here at the plinth, and elevation is 0 obviously. So elevation plinth starts at 0, and then the remaining story heights will insert. So the height of the 2.45 came from 0.45, and then the foundation depth I took as 2 meters. So that's how it came to 2.45. Now the next story is 4.2 meters. So this will be in the story 2. This will be 4.2 meters. Okay, height. And then the next story we have 3 more stories here at 3.6 each. So next 3 stories will be 3.6 here. Okay, so 3.6, and then we have to add another story here. Add story, keep existing story heights. Okay, story height here is 3.6 and so my laptop has hanged a little bit to wait for it to respond back. Yeah, we are back here now. Story 5 here. So this is G+1, G+2, G+3, and now we'll go for the headroom or the Monty room. Some people say add story, keep existing story heights. So this will be 3 meters. Why 3 meters? You can see the Monty here. This is at 3 meters. So the Monty for the Monty will take 3 meters here. 3 meters add story 1 and number of add story 1 from existing story 5 and insert above story 5. Click on OK. And this time it is story. I'll just call it the Monty level. Monty, I'll just call it Monty level. Yeah. Monty SSL I should call it, but okay, it's okay. Monty level. So this is the plinth level, and then we have the other stories here, and these are the stories which you created, and I'll click on OK, and then the stories are created. So click on OK once again. So here we'll find that the stories will be created here. As you can see, stories are created, and you have a by default in Etabs 2016 a plan view, and we have a 3D view here. So these two default views are present here, and you can move here like this, okay, to all the stories here. So first of all, if you go and define, we'll go and define the material properties, and we'll define the material properties of concrete and then steel, the essential material properties we need to define. Okay, so we will define the materials now. So we'll go to define and material properties. So we'll click on add new material, and we'll use India here and concrete. First of all, we'll define the M25 grade of concrete here. You can see default properties. If you want to modify them, you can just modify them, but we use the parameters which are there, and then click on OK, and then we'll add another material here, India, and then we'll use the option of rebar, and in this we'll use the steel here, which is Fe500 steel, and click on OK, and then you can see the properties of Fe500 steel which is present here, and then we click on OK, and you can click on OK. So after materials is defined, next we define the section properties here. So earlier I've done some analysis in STAT, and this was the section size which came for the column. So I'm going to take this section size for the columns, which is 400 into 1200, which we'll take for the columns here, and we can just do in this concrete column option, I can just edit this. So just double click on this, and this will select M25 concrete column is selected, and we will select this option of what was the size again, it was 400 into 1200. So property name C for column 400 into 1200. Okay, so this is the size here, and depth and width here is there. Width is 400 and depth is 1200. So you can see this is the size here, and these are the maximum possible or the probable amount of reinforcement which we are going to have here. And you can see the property modifiers here, and moment of inertia in the two axes as per the IS code can be reduced, and let me just show you the exact clause for that also. You can find this in IS 1893 2016 page number 14 and clause 6.3.1, that for columns you can reduce up to 70%, and for beams you can go for 35%. So you can apply this separately, or you can apply this in this portion directly also. So I'm going to apply the stiffness modifier directly here, and this will be 0.7, and this will also be moment of inertia 0.7. So then click on OK, and then this reinforcement also, just change the reinforcement to the HYSD 500, which we have just created, and make sure, since we've edited the already a column property, so that's why already this column is selected, otherwise you have to do this manually. Reinforcement configuration is rectangular, and clear cover for confinement bars is 40. Number of reinforcement bars we can change, and reinforcement bar, these areas also you can change here easily. Okay, so and okay, so then click on OK, and then click on OK here, and then I'm going to add a property for plane beam here, and let's go, or you can just use this and edit this. Okay, this will be P, or let's go B for beam, and this will be 300 plus 500 for the normal plane beams. We're going to do this M25 obviously, and modifiers, this is for beams, it will be 0.35 and 0.35 for the beams. Click on OK, and in the rebars just make sure this is beams, and then you the HYSD 500, which we have just done here. Okay, so let's just run this from non-zero to group center, or your group center. I can just give this as default now, and yeah, this size 500, width will be 300, and depth will be 500 for this one, and then we'll click on OK. So these two things are done here, and then we can click on OK, or I'll want to just add another property, or just take this property and add copy of property, and we'll add a copy of this property here, and this will be 300 into 600. So if any thing doesn't pass, anything goes beyond this, and you can take a size beyond this also. But now let's go, I'll go with this 300 into 500 itself for the plane beam, and 300 to 600 for the roof beams. Okay, so property modifiers here once again already, because we have copied this, that's why we don't need to change. That's the importance for that's the ease of copying things. Okay, then click on OK. Metal properties defined. Section properties have been defined by us. Okay, let me just check the modifiers once again. Okay, this is okay. Two things have been defined by us. Click on OK. Now the next thing which you need to define is the you can see, if you are using this soil profile, soil structure interaction, then you can use this. We're not currently using the soil structure interaction or springs here. Okay, so that's why I not use this. Then we go with the diaphragms. So what are the diaphragms? Basically, a float diaphragm shall be considered to be, basically it transfers the load of the vertical elements to the other elements. Okay, so and diaphragm can be flexible, or the diaphragm can be rigid here. Okay, let me just show you the definition of the diaphragm itself, and just pause. So basically diaphragm in buildings whose diaphragms cannot provide rigid or horizontal support action on their own, design solution shall be distributed to the various lateral force resisting system, considering the flexibility of diaphragm. Diaphragm shall be considered to be flexible if the deformed such that the maximum lateral displacement measured from the part of the deformed shape at any point of the structure is more than 1.2 times the average displacement of the entire diaphragm. Okay, so the diaphragm is a horizontal or a nearly horizontal member which transfers the force to the vertical members. So basically it's that. Basically it is a kind of slab here, a diaphragm. Okay, so usually reinforced concrete monolithic slab or floors of those who consist of prefabricated or precast elements then we consider as rigid diaphragm action. So normal cases it should be considered rigid diaphragm action. If this criteria doesn't satisfy, there is a displacement, then we should consider this as flexible diaphragm. So diaphragm should be considered here and should be considered rigid to begin with. And we'll add a new diaphragm here because we want to add a diaphragm for all the floors. So if you check our building, then our building is G+3, okay, and we'll add diaphragms in these three levels. Since in this particular level I'm not providing the grade slab or the RCC slab, we're directly giving a PCC over the in the plinth level, so we'll consider diaphragm in 3. You can also consider diaphragm in the headroom level also as well, okay, but we're not using it for the wing load analysis. So we're using diaphragm for these 3 levels. We'll create 3 diaphragms now, okay. Define and then diaphragms. We'll add new diaphragm D2, which is also rigid, and another diaphragm D3, which is also rigid. We'll check D1 because it was earlier and whether it's rigid or not. Yeah, it is obviously a rigid diaphragm, and click on OK. So diaphragms are defined. Piers and squandrels need to be defined for the lift portion, shear wall portions. So we can define this now, or we can define this later as well, okay. So we'll define the later up while when you're modeling the shear walls, okay. So group definition, if you want different colors for different groups, and we can do this. Section cuts can be given for sections of the shear wall, okay. Functions, now functions, response spectrum function we can define, okay. So response spectrum function we can define. So this response spectrum function we will define as per the Indian code. This is our old version of Etabs, so we don't have the latest code. We have 2002, but if you use the latest version, you have the 2016 version of the code here. So add new function here, and then you have to decide on some factors here. So function 1, I'll just call it RS, okay. And then the seismic zone factor for our building lies in seismic zone 5. So our building lies in seismic zone 5. So as per the table mentioned in the code, that is table number 3, the Z will be seismic zone factor will be 0.36. So that's what exactly they have taken here. And then we have the table of the time period and the acceleration of this structure here. Okay, so now what is this time period and acceleration table actually? Then we can just check this also, okay. So basically when you open the code here, and we have, first of all, we have to calculate the time period. Time period should be calculated, and the time period should be calculated with this formula, clause 7.6.2, page number 21. Okay, so the building dimensions available here, if you just, even if I add the center to center diagrams which we have taken in this, so in this direction it is this, and in this direction it is this value which we have taken actually, okay. So what is this direction in stat, which is 54.5, so no stat Etabs, it is x direction. In x direction it is 54.5, okay, so pretty good. So x direction, this is 54.5, and then in the other direction which we have here, we have done this here, right, in this. So this is 12.05. So let's put here, this will be 12.05, and the height of the building is 15 meters except the headroom portion. So TAX, the calculation will be this will be 15, and this will also be 15. Height is same for the building, but this will be 54.5. Let's replace this, and let's replace this with this. Okay, so pretty good. Let's open the if you have Excel, then that should be good. This calculation we want to do, right? Let's go ahead and copy this in Excel, that will be better. Okay, I want to copy this. So this thing, this is the thing, and let's write is equals to bracket 0.09. Just zoom in this. Okay, let me just complete this first. 0.9 into 15 and divided by SQRT of 54.5. Bracket close, enter. So this gives the value as 0.18. Okay, now I can zoom in because I'm not in any function. Okay, good enough. Now this is let me just copy this one here, and place of this will put square root of 12.05, which is 0.38 basically. Or 0.39 also, you can just take 0.39 if you round up. So 0.18 and 0.39 is the case. So these are the 2 time periods in the 2 directions, and now let's look for the we have the time period. Now let's look for the acceleration. So the acceleration will be decided by these factors that we already know. It is 0.36 for zone 2, 0.6 by 2, which will be 0.18. SA by G will depend on the time period which I've just calculated. So both these time periods lie in this range. So SA by G will be 2.5. R is the response reduction factor, and response reduction factor will be 5 for special movement resisting frame, which is considered for ductile detailing, and I will be 1 in this case for all other building here. So let's you can calculate the value of AH in the X and Z here. So S by G is 0.5, and AH will be 0.18 into 2.5 divided by 5 by 1, which will be 0.09. So 0.09 will be the acceleration into the base shear, which is VB. That will be the calculation for the seismic load. And in the vertical direction, when you will apply the earthquake in the vertical direction, that will be 2 by 3 into this value, and 2 by 3 into this value will be 0.06. So the acceleration for the vertical direction will be 0.06, and for the lateral direction it will be 0.09. And if you're wondering why we are taking the loads in the vertical direction as well, because our building lies in seismic zone 5. Okay, so if your building lies in seismic zone 5 as per, look at the clause 6.3.3 in the IS 189/2016. If your structure lies in seismic zone 4 or 5, or if your building has planned or irregularities, restaurant, soft soil, bridge, long span, large horizontal overrun, that is means the large cantilevers, so then you have to consider the vertical effects. So you have to consider the vertical effects undoubtedly. So when we are to consider the vertical effects, we have to take this design acceleration into account. Okay, so that's the base shear here. So 0.09 is the design acceleration for the time period here. So in this particular option here, you can find there are various values of time period which are defined here, and then we have the various values which are available here. You can see 0.1224, 0.036 is the maximum value, which is for 0.1. So we'll let the software automatically calculate this. Okay, but we have just shown you the manual part as well. If you because it's shared, like we have to do it manually, insert, if you do manual calculation also, that will be required. So that's why it's better to know this. Okay, so you can click on OK, and then you just modify this, and you can just see these are the things which you had inserted here for this response spectrum function here. So we'll just click on OK, and this is our response spectrum function here, RS, and we will click we can define another response spectrum function for the vertical direction as well. So we'll define this as RSZ, because in this particular software we cannot apply the response spectrum or the seismic load in the Z direction, or the in this case it will be the Z direction or the vertical direction directly. Okay, so that's why we have to add this manually, and we have to use a separate table for that. Edit the table manually. Sorry, I'm like this. So RSZ, or let's call it SLZ, that will be better. SLZ or SL vertical, or SLV will be better. SL, seismic load in the vertical direction, to be short. Soil type is 2. Okay, by the way, I missed, I think, the soil type to explain soil type to you in the previous assignment here. So for the soil type, you can go to there is a table for the soil type as well in the code. So you can see in clause number this one 6.4.2.1 earlier also you have a table there which describes the soil type, which you can see rock or hard soil type 1, medium or steep soil is soil type 2, and soil type 3 is this one. This is in page number 9, and in table number 2 you'll find this there are 3 types of soil and the detailed classification of the N value. If N value is above 30, then it is rock soil. If N value lies between 10 and 30, then it is medium soil, and if N value is lower than that, then it obviously is soft soil. So the detailed classifications also you will obtain. So from the soil test report you can just find this particular thing, and for your curiosity I'll also show you the soil test report for this particular building, so that exactly you can know where to find in the soil test report. So our building has been decided at foundation depth 2 meters. So you can see in this soil test report here. So here for a building depth of 1.5, between 1.5 and 2. So 1.5 the SPT value came. So what is the N value here? You can see 4. For 0 to 150, 150 to 300, it is 4, and then it is 5. So SPT value is the addition of these two, 5 plus 4, and then it is 9. So even if you take 9, then you can see which range it lies. If this is 9, so if this is N less than 10, this will come under soft soil. But okay, there is a thing. What it has written, title description: stiff to very stiff, silty clay, clayey silt, traces of sand. So this is the description, and this is the hard. So hard, you can see SPT is pretty much, you can see 15, 26 for SPT value is 41. So if you look ahead and go with the 41 SPT value, is more than 30. So stiff to hard clay is more than 30, and if you want to go the hard, then you have to go to depth of 9 to 9.6 meter for the footing. Then you can get the hard soil, extremely hard soil. But if you are asking to stay in this range, so soil test report suggests that this is the stiff to extremely stiff. By the way, if anyone knows more about this SPT N values, because I don't have that much knowledge about this, so they can comment below, or I will study more and make a more detailed description. But you can find this SPT and value check in the soil test report. Apart from that, there is no other way. Okay, let's come back to our video here. Okay, so where were you? Yeah, we were doing this, and in the vertical direction we'll have to convert this into user defined, and our acceleration in the vertical direction was 0.06, which we had calculated in this sheet here, which you can download from the description. And if I forget to put the link, just tell me in the comments, I will just put it. Okay, because sometimes I forget, because I am the only one doing the editing, uploading everything. So 0.06 is the thing. For 0 for all time periods, let's put modify, and you can put the 0.06 option here for all the time periods. Okay, or we can just delete the time period in between. For 0, the value will be 0.06, add, not add, it will modify, right? Modify, and for time period of 10, it will be 0.06, add. Okay, so for 5 also will 0.06 add. So everything will be 0.06 in here. So we have just added the seismic load in vertical direction. For the acceleration value, we have just added it manually, and then you can click on OK. So this definition is complete, and then we are going to define the mass source here. So mass source I think we'll define later. After let us define the basic load cases first. Model load cases, default model load cases, the value is 12. If it doesn't satisfy, I think it will be 12 number of modes. If our clause or criteria after the analysis doesn't satisfy this particular clause, which I'll just show you, that is, so first of all, number of modes should be considered. A number of modes you to be used in the analysis for the earthquake shaking along a considered direction should be some such that the sum total of model masses of these modes is considered at least 90% of the total seismic mass, as per this 7.7.5.2 clause. And in table number 6, it is also written that for seismic zone 2 and 3, it should be ensured that the first 3 modes should contribute at least 65%, and for the seismic zone 4 and 5, another additional criteria is also there. But this criteria I got from professors that it is under revision. So basically we have to follow only this particular first clause, that is the first 3 modes should contribute 65% of mass participation factor. So if this doesn't satisfy, then we can increase the number of modes here. So for now we'll keep this as default. So we'll go to define, and then model cases are defined. You can see how I have one serial by, so that we don't have any options in between. P delta options we're not using in this particular video. We'll just make a separate video on this. By the way, for this building we won't need, that's my view. So we'll go to load patterns here, and dead we have defined. So this particular dead load we are going to use only for the self weight. Okay, so this particular dead load is you will use only for the self weight. We'll use another dead load here. We will call this other dead, and this all the dead load, wall load, floor finish load, and any other dead load which is possible. We'll add in this other other dead load case here. So then self weight multiplier here. We'll just keep it 0, and then we'll add a new load, and we'll add the seismic load obviously, and load type this will be seismic, and here automatic load, select 1893 2016, but I'm using the older version, so that's why I have to use 2002 now. So we'll select the IS 2002, and then name this will be, I'll name this seismic load in X direction here, and add new load. Okay, and then we'll add the seismic load in the Y direction, which is the other lateral direction, and this will be add new load. And then we'll add the wind load WL, and this will be wind, and the automatic load. By the way, the updated wind load code is there here, so you'll use the updated wind load code, that is 2015 code, and in this we'll use add new load. Okay, in this seismic load we'll modify the lateral load here, and just make sure you change your zone. So you can see only 2 directions this is in this version Etabs are available. In the Z direction, the vertical direction, this is not available, so you have to apply in that's why you would apply in other ways. Okay, seismic zone factor, zone 5 factor we've selected. Soil type I've already explained, import factor is 1. Gas concentration rate is 5 for SMRF building. Let the program calculate the time period, otherwise we already have calculated, we can insert it here also, so there is no problem in that. Okay, so here bottom story, let us keep this as plinth level and click on OK. And seismic Y also modify lateral load, and Y direction with eccentricity will consider, and obviously this will be the plinth level, and let the program calculate, and then click on OK. So this is fine. And wind load, modify lateral load here, and basic wind speed, you have to check the code for the basic wind speed here. I have a document here which you can use. I'll give you in the download link in the description, which you can use for these things. You can see in page number 3 of code, you can find the basic wind speed here, which is 55 for this case. So this is 55, and terrain category if you want to know, you can find in this trend category page number 8. So 1 is the worst possible trend. There is everything is open here. So trend category 1 and importance factor 1, risk coefficient 1, everything 1. So you can find in the document the other things. I'm not going to just bottom story is obviously plinth level for all the lateral loads, and then CP and CP windward coefficient and leeward coefficient. So this is obviously the most possible case. So if you want to go in detail, then we can go in detail, but mostly in these cases this will be the case. If you want to go dig into the dig deep into this wind load criteria, you can check the CPE minus CPI, and by the way, if we obtain some values and windward leeward, you can calculate everything separately, but I'm not going to do that because this is sufficient in most cases. We can also do one also, just to be more on the safer side, but I'll keep it this way for now, wind load, and then we'll click on OK. So this, having this done, our time period for our building in the two directions which we had calculated, this was done, and we had defined the loads also, okay, and load patterns also. Then we have the shell loads uniform load set. You can add the shell loads uniform load set, and then you can add the load combinations. We'll do the load combinations later after doing the other things here, okay. So in the third phase, what we'll do, we'll just define, we can go to define the mass source here. So seismic mass source is percentage of the live load and full amount of the dead load. You can find in various parts of the code here, in which this is written actually. So you can find it there, and you can read it, and the percentage of the live load which you need to take, you can find in table number 10 of the code here. So in the table number 10, you will find that if for live load, if your live load is up to 3, then you will take 25%, and if your live load is more than 3, then you have to take in the seismic weight, that is you have to take 50%, which is, this is the table number 10 which I was searching actually. So okay, seismic weight of the floor, very beautiful definition of the seismic weight is given. I love this definition, 3.26 of the code. So it is sum of the dead load to the floor, appropriate contributions of weight of columns, walls, and any other permanent elements from the stories above, finishes and services, and appropriate amounts of specified amount of imposed loads on the floor. So the translation of this is dead load plus a percentage of the live load as per table number 10. Okay. So yes, mass source, we'll do this. I like to do this, turn off this element self mass and specified load patterns, and dead load I like to turn it as 1, and other dead also 1, which is the total dead load here. And then for the live here, live load will be 4 or more than 3 in our case, so it will be 0.5, will not be 2, I think. So live load will be 2, 0.5 multiplier. So enter, and include the vertical mass, because we are to provide the this thing in the vertical direction, or earthquake in the vertical direction also, so we need this. So mass structure 1, okay, this is fine, and then this will be selected by default, so this will be 1. So we have defined this, and you can also define the slab sections as well. Slab sections, slab 1 will be the default here. Let's change that only, M25. Modify size, auto, user defined, let's give this 150, and then click on OK. And here 150. Oh no, this will be auto, so sorry, this will be auto nomination size. And now we have this shell thin, so we'll use the shell thin option here because we want movements here. If we don't want movement, then you will use the membrane option. Okay, modifiers, here we'll keep this everything normal here. Property nodes, don't want to create any property nodes. Slab 150 on slab, I'll just do solid slab 150, because if any slab fails, then we might use different size also. And then click on OK. So definitions are complete as of now. Now we'll go to the base level. This is the base level, right? Minus 2.45 is so base level, and now we'll go and joint restraints and fixed support. You can select this. Okay, so you can see this, it doesn't get selected once we apply the columns. You can see above also one, this is not selected. Once you apply the column, then this will be selected. Okay, so start from the plinth level, right? So in the plinth level, we'll go to look, check out the buttons in the left of your screen, and we will go here and quick draw columns. Our columns are the size, this one is the size, and in our building the columns are like this, placed like this. No, it should be at an angle here. It shouldn't be like this. It should be like this. Let's change the angle to 90. So now it's okay. Yeah, now it's fine. The columns which we have presented here, and in the next level also we'll just do the same. We could copy this also, by the way, to the other levels. Okay, let me just copy this just to show you guys. Okay, so 3D view, we can just hold your mouse middle button and your shift button to just play around with the 3D view here. Okay, so so this is basically the plan view, right? This goes at the top. Okay, so by the way, what we can do, we'll just select this thing here. Okay, so 3D view, let's select the 3D here and select these here, and you can see the grids are selected here. So you can also go click on elevation here, and in the 3D view you can see the elevation of we have the grid number 2. Let's go elevation of 2, apply, and if we just select this particular level without the joint intersections, if you select this particular level, we select it, and another grid we need, this will be grid number 3. So elevation view, elevation, and here grid number 3, apply, okay, and select them like this. Okay, you can see the 3D view also, this is selected like this, and we can go to edit and use the option of replicate, and replicate this along the story here. So we have copied in story 2. Okay, so this is the base, this is the plinth, and this is the story 2. So we can copy this in story 3. You can just hover over to apply just to check here. So we can see no difference is there. So story 4, if you just do, then it is all right. So this was story 3. So then we want to copy this in story 4 and story 5. So just hover over to this, and you can check this like this, and click on apply and click on OK. So you can see it has been done up to story 3 and story 5. You can even extrude this to check here using this option, extruded view, just to check the columns sizes here like this. Okay, So I'll just go back to this normal view here, and this is it. So now we have modeled the columns. Now let's go for back in the plan and back in the plinth level, because the columns beams will be at the plinth level obviously, and let's model the plinth beams here. First of all, let's apply the main beams here. So quick draw beams. Here let's select the plinth beam option, be 300 into 500 here. So you can draw the beams like this. Can I just draw them like all the other beams are also getting created? So I'll just be a little bit patient, or I can delete this. I think I don't need them, need it now. And I can also go like this, I guess. Now I have to go serial by. Can I go this way? No. Okay, so this is done, and once this is done, and for along these edges, these are quite large sizes, so we want to also ensure that properly beams are provided in on these edges also, because there will be some UDL here. So you can go for a lower size. I think we'll go for 300 into 400 along this size. So we'll go to define section properties, frame sections, and we'll define a new beam. We'll start with this be 300 into 500, and we'll just add copy of property, and so add copy of property, and this will be B 300 into 400, 300 into 400. This will be the size, and remaining things will be the same. And then click on property modifiers. I hope that will already be there, right? So then click on OK, and then click on OK. So we'll use this size for the parapet wall, horizontal portion, because we will need it, especially in the upper floors. Here we can support web breaker, but in the upper floors we'll definitely need it. So this is the model here up to the plinth level here, and we can see the model in 3D view as well. You can see this in the extruded view. So you can see strong columns, weak beams. That's our motto. Rotate it with the help of your mouse middle button and shift. You can see this. So basically you can see the type of support which is there. This denotes a pin support. So we want to change that. We'll go to a plan, and we'll go to the bottommost part, which is base, and click on apply. And then we'll turn off the extruded view for now, and in this case we'll select everything which has the supports here, and we'll assign them and assign joint restraints, and the restraints will be assigned as fixed restraints. Click on apply and click on OK. So the restraints are now applied here. So now let's model the secondary beams also. So primary beams are modeled, as you can see here for the plinth beams. Let's model the secondary beams also. So we'll go to plan here, and we'll go to the plinth level and click on apply, and we'll model the secondary beams now. So to model the secondary beams, we need to check the dimensions of from the our plan here. Okay, so we'll check the dimensions from the plan, and then we'll model the beams here. Okay, so first of all, let's model beams around this lift portion. So this will also be useful for our shear wall portions also. All right, so let's model a beam here, and then this is already included in the primary beam, and then model this one and this one as well. Okay, so let's do this. So this is the portion for the staircase. So just copy this particular beam and we'll see the distance from our CAD file. Distance is from this grid line to the center, approximately it is 1.85. that is the distance. Okay, so move back to Etabs. So this member is selected here like this. You can see Ctrl plus C and Ctrl plus V. So the we'll paste the coordinates here like this you can do, or else what you can do, just select this and go to edit and you can go to replicate, right? This is the better way. So and then you can have the linear. So here you can see the axis here, which is the axis here, y-axis is this. So if you move downwards, so this will be in the negative direction. So we'll give a negative minus 1.85 here, right? So minus what was the selection, this, there was a selection there. So negative minus 1.85 and number 1. So because you want one number of copy, if it copy twice, then it will get to 2 members. Okay, so just hover about to apply. You can see the effect here without clicking, and then you can click actually. Okay, and then here this secondary beam is done. This secondary beam will act for the staircase as well as for the lift portion also. So if you want to release the moment in this, suppose in this both the ends are pinned, okay, so there will be no movements in here because there is no columns here, so we won't consider this as fixed support. We'll consider this as simply supported. So what happens is the moment at the top end, that is it is transferred to the bottom. So simply what you do, just let me just show you. Select this and assign, and in this assign option we have this frame, and this frame releases partially. So in Etabs, M33 is the major axis, so we just release the movements in the start and the end fully. So it will act as simply supported at here and here, this point and this point. So it will indeed act some point load on this beam, so it will affect the design of this beam in that way. But this is it, and click on apply, and when you click on apply, you can see this denotation that this movements have been released, and you can click on OK here. So the moments have been released in this beam, and as I told you, this beam can be used for the staircase portion as well when you go up also, because this portion is obviously similar, and obviously we'll need a beam in this area as well for the staircase portion. So this can be used for the staircase portion as well as for the lift portion also. So now there is another beam. We can replicate this particular beam to this area just to do this. So let's see the approximate length here from this center line to this is 3.45 actually, approximately 3.45 for this beam to this beam center. So if I select this and press Ctrl plus R, which is the shortcut for replicate, and I forgot the value, this 3.45, right? 3.45. So 3.45 is in which direction? It is in the x direction, so it is in the negative x direction. So minus 3.45. So minus 3.45. We want one number, and click on apply here. So now this has been copied, but we find that this beam should intersect here. Okay, so let us try to intersect these beams here. Edit frames and divide frames. We have an option. Let's try that. Okay, so let's try again. These two beams are selected. Go to edit and edit frames, divide frames, divide at intersection, and selected frames at joints. Okay. So you can see this is divided here like this. This beam is divided here like this. So if we plan to provide the shear wall like this, from here to here directly, this portion, then this is beam is not required. And if we require this beam, then we need to give this, obviously. Okay. And but let's skip this beam for now. So okay, this is done. And you can see in the this also. So this is, there is one beam, secondary beam created, and there is one secondary beam created, and there will be apply shear wall later anyway, so not concerned with that much. Okay. And this walls also, there is also already beams there. Okay, so there is not an issue here. And these beams we can choose to provide or not provide this, maybe ignore this as well. This is actually 175 mm wall. Okay. You can provide one beam here as well for this, and I think you can provide another beam for again for here for this. Okay. So let's see this distance. By the way, if we can also release the moment here for this and this as well. So select this one. So this is the bottom end, this is the top end. So if you want to do the bottom end, this should be the start. Like this, let's go assign joint, now joint frame release partial fixity, and this should be at the major and at the start, right? Apply. So you can see it's applied at the start. Now select this, and this is should be at the end. So bottom should be the 1 and 2 should be end, so it should be at the end. So just select end and do like this. Okay. So yeah, you're happy with that. You can when you model, I think I should do everything in one go. That would save us a lot of time here. Okay. So another secondary beam we need to add here. This is the secondary beam here, which we need to add. Approximately it is 2.65. So yeah, this is also 2.65 approximately, this beam also. So this one, so press Ctrl plus R, replicate, and in this y direction, this is 2.65, 0 minus 2.65, hover over, yeah, good, and close. We'll apply the we'll realize the moment later. Okay. So this is done. And now for leave one span, and then next span also 2.65 offset, next two spans actually 2.665 offset we can do. Select these two, actually not to press Ctrl, select these two, Ctrl plus R, replicate 2.65, and hover over to apply. So we're good, and okay. So now let's go for this staircase portion. You see this portion is different, this staircase portion. So here in the staircase portion, the things will be the same, but it's only in the separate direction here. Okay. So here it is 1.375 from this center to this center. So let's complete this one first, or I think we can complete this one first. This is 1.8 from this one. Let's complete this beam first. 1.8 from, select this, Ctrl plus C, and not Ctrl plus C, not required, just select this and Ctrl plus R to replicate. And then we have in the X direction, it is 1.8, so it will be minus 1.8. Over about apply just to check this, we are good with this, and click on OK. Now keep this window open, select this, and we have the, just take the value once again, 1.375 downwards, so negative. So make this 0 and make this as 1.375. so y minus 1.375. so just apply here and click on OK, and one intersection here, go to edit and edit frames, and divide frames, break at intersection points, apply, and OK. So yeah, this is done here. Let's see if we need any other secondary beams here. This is very close, I'll ignore this, so we don't need, and the smaller walls we'll ignore those as well. It should be sufficient to take loads as per my analysis. So let's put the uh, you know release the moments, the secondary beams. So both ends they should be. So we'll go to assign frame and property release partially, and both at the start and the end will release this moment here. And in this, for this only at the start will do, because this is a continuous one, only at the start will do. And for this one only at the end will do. Similarly for this one we'll do only at the start, and for this one we'll do only at the end. So it goes left to right, then it actually depends on the coordinate system. What is the since the coordinate system goes positive in this way, so this is start, this is end, and for downwards also it goes positive this way, so this is start, this is end, like this. Okay, so it depends on this particular system here. So it goes like this is positive, this goes like this is positive. So let's define the starting and the ending here. So here now we'll go, this is the start here, and click on apply, and this is the end here, click on apply, this is okay, and we'll click on OK here. So I think we are done here for this particular model. That is up to the plinth level we are done. I'll just look into the extruded view just to visualize the concept here. Maybe in the 3D view will do that. This is the extruded view. Okay, yeah, just click on escape to get back to the normal view. I think the software bugged out due to this. Anyway, let's just complete our process. If this end partial fixity removed, then we should be able to see the extruded view. Let's continue for the next floor. So for the next floor, this is interesting. Now the primary members, I think we don't need to copy. We can we can copy. We don't need to do it again. But before that, with all the secondary beams, if you want to assign a different property for the secondary beams, we can do that. But for the plinth beam, we'll keep the same, or we can assign the property which we assign to the cantilever portions as well, in the portion of the secondary beams, at least in some portions. So let's go to plan, and let's go to the plinth level, apply, and OK. And in here, the secondary beams, we'll choose this secondary beam. I think this one will have significant loads. So, but then also this one, and this one, and this one, and this one also, this one, and this one, and these are the secondary beams which are there. And assign frame section properties, we'll assign this in the one 300 to 400, this one will apply. Okay, so you can see all the properties here like this. You can see section properties 300 to 400, you can see this like this. So 300 to 400 remaining are 300 to 500, that's the property which we have applied at the plinth level here. Okay, so now plinth level is complete. Now let's look, let you display undeformed shape, and then you can look into the extruded view. Okay, to go to display, and then you have to click on the undeformed shape, and then you can look into the extruded view if you want. So you can now visualize that how much column offset will be in the sides actually. That's why I wanted to look this. Okay, so go to display undeformed shape. Now this is completed in this portion. Now we'll move on to the next portion which we need to complete here is the next level. But before that, I think we can copy a significant portion of this to the next level here. So we'll copy this, and I'll no need to press Ctrl. It's similar to AutoCAD. Instead, you need to press Ctrl. Okay, that's why I'm telling you, those who are STAD users. So we'll copy the primary beams and not copy the column because they are already done. And this portion also, yes, this portion of secondary beams also, this will be, because this is for the staircase, this is also present in all the floors. Okay, so we'll copy this also. This portion only the primary beam is there, secondary beam is not there here actually. Staircase portion, this one is there. this one is there, and this one is there. So yeah, I think pretty much we have covered all the beams which we want to copy. So it seems like, yeah, everything has been copied here. So here we go to the 3D option. Yeah, that will look better in this, because this option, this will be copied in all the levels here. Okay, so we press Ctrl plus R, that is replicate, will replicate according to story. So let's see if we just hover over to plinth beam and I click on apply here. So this actually will be copied in all the levels from story 2 to this story, because this are the beams, primary beams, and the staircase beams which will be present in all the floors. So let's just click on apply and click on OK. So you can see now the modeling has been done, completed for the plinth level, but for the remaining floors we need to model the other portions for the secondary beams as well. Now you can go to display, undeformed shape, and then you can check the extruded view of this building as well. So still this is incomplete, because we need to model the Mumty, and also we need to model the secondary views wherever they are present, because we cannot ignore the effect of the secondary beams on such a large building. It's around 8,000 square feet. So let's do that. So let's go back to the normal view, and then let's model the for the Monty as well. So for that we will go to the plan view of the topmost floor below the Monty, the terrace level you will say, and then we will copy this the beams which will be covered here, and yes, pretty much these beams, and this and this, and this portion will also be there. The cantilever is also there as per the plan. If you see the plan here in the AutoCAD, the terrace portion, you can see this. Yeah, back portion is not there probably. The front portion is there, so it will end here. Okay, it will end here. This portion is not there. This portion is there. So yes, this portion is not required. So control and select to deselect this. This portion is not required. This portion is required. Similarly, do for this portion. Let me check if everything is done or not. Yeah, seems like everything is done. Now we can replicate this. Ctrl plus R, story, multi-level, apply and OK. And then we'll go back to the 3D view. You can see this is done, but we need the columns to be connected here. So for that, simply go to the plan view and the multi-level. Okay, and we'll apply the columns here. Okay. Oh, it is a different option here. You can use this option. See, yeah, this option is better. Oh, I think I have assigned the column in the wrong location. Ctrl plus Z to remove this. Okay, escape, and then we'll go to 3D view. Check this. Okay, so let's do the floors one by one. Let's go to the plan view and let's open the story 2. normal view. Let's open the CAD. In this particular floor we have these three beams coming at 2600. So let's apply this beams here, three beams here, leaving two spans. We have these three beams up to the staircase portion at 2600. So selecting this, this and this, control R, minus 2.6, apply. Okay, so let's see what else we have in store for us. We have to give this beam as well, so this beam as well, I think this is in the same location, 2.6. so this will also give here. Let's see for how many spans we have this beam. Yeah, this is also after the staircase for 3 spans, 1 2 3 spans. So for after staircase 1 2 and 3, 2.6, apply. And for this span there is something different, the distance here. Let's check the distance here. This is 4.95. so 4.95 distance here, minus 4.95, apply. And then let's check the remaining thing here. This is also at the same level, I hope, but no, it's not the same level. From here we can take 1.775. okay, we'll take that. Let's select this, and positive it will be 1.775. Click on apply. And let's see if we have any other things, major beams which we need to provide. Yeah, we can also provide this, rather it is very close. We could have avoided this, but now the planning is done. So it is 1.378 from this last two spans, I guess. Yeah, last two spans, this one and this one, not this one. Component is select this one, so it is minus 1.378, and click on apply. It's coming with the same zone. It shouldn't come, I think. Yeah, there's nothing much we can do here. It's going the same zone. Okay, apply. And okay, might be some major minor difference which will cause very differential moments here, so we could have avoided this in practical. Let's see, I can just delete this now. Can yeah, anyway, it will not come here. Actually this load will be transferred in another vertical member here, like this. So let's model this up to this. Let's ignore this small portion. It shouldn't be major problem here, or else we can model this particular beam at 2.15 to if you want to be accurate. Let's do this, model this particular beam at 2.15 from this vertical member here. So it will create a lot of movements in this main beam, but I think we if we want to ignore this portion, then okay, otherwise we need to do this kind of. So to decide, okay, let's do this. So 2.15 from this one, control plus R, minus 2.15, apply. Okay, let me take the beams here, and this will be obviously a secondary beam, so 300 into 400 should do, I think. From here to, let's go 90 degree, and later we can cut 180 degree. Yeah, 180 degree, let's go. Later we can cut, I think. Select this, and select this, and select this, and then go to edit and edit frames here. Divide frames, break at intersection points, apply, okay, and then we can delete this. And then I think we can even join this beam also, like edit and edit frames and join frames like this. You can join this frames also like this. This is divided, but this is right. So this is better, a lot better in this aspect. So now for these secondary beams, we need to change the type of the staircase is already decided. So for all this, we need to change, I think. So assign frame section property. Which one do we want? 300 into 500. Let's give. Okay. So secondary beam properties has been assigned. Now only the restraints we need to check. Okay. So let's select this first and assign frame releases MZ direction obviously, and this will be released at the start. Okay, then this is continuous, then let's release here at the end. Okay, this is the done, and let's do the same for this. This will be at the start and this one at the end. Now this one both at the start and end, and this one also should be both at the start and end, and this one also both at the start and end, and this one I don't want to release the moment on a secondary beam here. Technically it should be at both the start at the end, and should act as a point load here, but not sure I should do that. Okay, let me just do this. This will be definitely at the end obviously, and this is continuous, and this could be at the start. I think this is okay. If you disagree, then you can let me know in the comment section with the reason. That's I teach you, you teach me, like Ash said. Okay, so here now this secondary beam is done, and all the properties are also assigned in this floor. So we can move into the next floor. Yeah, we can model the slabs also, but let's keep that for now. We'll do that later, the next floor. So next two floors have similar arrangement. Okay, so this floor and this floor similar arrangements. If you do one, then you will do both. Then obviously the terrace, we don't need to do any secondary beams in the terrace. So let's do this one. So we have to know the distance here. So we have a common 2.362. This is the distance, and it is applied on all the spans. So it is pretty much simple. This secondary beam portion 2.362. So let's select everything here which you got except the staircase. And Ctrl plus R, replicate, and 0 in this direction obviously, in the Y minus 2.362, and whatever to apply. This seems good. Okay, and click on OK. And I want to just release the moment here, and yeah, assign frame releases, partial releases MZ at the start, apply, and here I want to release it at the end, apply. Here I want to release at the start, here I want to release this at the end. Here also the start for this one continuous, and then release at the end. Done. Click on OK. Now time for changing the properties of the secondary beam. Select this, select this, select this, select this, select this, because I believe that much depth would not be required. Okay, staircase is already provided, so I've got no staircase beams. Yeah, this one, assign frame section property 300 into 500. Let's go. 300 400 is for this cantilever portion, and then 300 to 500 is for this one. 300 to 600 is for should have been for the main beam, but I think I have not changed that. Okay, I need to change that. Okay, I'll change every thing later. From the top view, I think I can get access to all of this. Okay. Okay, so we'll change this later. Let's go to the next story. Next story is also similar to this. So in theory we could copy this to the next story also. Okay, so we just select this and select this. These are the secondary views, right? This also, this and this, and go to Ctrl plus R, story, and this will be story 4. So story 4, apply, and okay. So now move on to story 4. So you can see story 4, this is copied, and story 5 is the terrace floor. You don't need that thing. Now I will try to set my 3D view in such a way that this comes the top view. You get the top view actually. 3D view, yeah, that view is easy, but when you just rotate by mouse, you know, we don't get the actual top view, and I want to set the top view to the actual top view of the 3D building. We don't have an there is a way, easier way, I don't know. Let's see. 3D view is this, and now we'll go to view and set 3D view. Okay, fast view. Yeah, we have the fast view. So this should help x, and this is y. So x, y. This should give the top view, right? Yes, exactly. This is what I wanted. But display undeformed shape. But this is confusing a little bit. We don't get the exact view, so better I go and do it in the plan itself. That's better. So the plan 2, let me select this in the plan. It's better, a lot better way than doing this. I hope you're practicing with me. This is done, and to the next level. Oh, okay, this should also be done, right? Maybe copy this things like this. So there are no secondary views in between here. This one. Thing got all. The next floor. The issue with this thing which I'm doing is selecting everything in this one. If I mess up in one floor, then I have to do the entire thing once again. We have to like do the entire thing once again. So hope, just pray that we don't mess up. Pray for the best. I think this is the vertical ones are done. Horizontal ones. Select this like this. Okay, I think our primary beams are done on this level. Let's move on to the next story. Is actually similar story. So many shortcuts I think we could be using in this, but let's do this. First, I'm at the point where we could skip these parts, but I think it's not regard those who watched till now will watch anyway, so let's cover everything. So this is the thing here. And now after this selection of the primary beams, let's move on to the next level. Next level is actually the terrace level, so it will be easier to select because there are no secondary beams, or you can say less secondary beams apart from the stair portion. Okay. You can see all the primary beams property have been changed. So now I can say the modeling for this structure is complete. Let's go to 3D view. This is the modeling of the structure, which is complete. Oh no, it's not complete. Why did I say that? I'll not assign the slabs. And also the staircase portion I think we'll skip this part, the staircase part. Let's do that, not do that now. So go to the plan. To plinth level there will be no slabs. Here there will be slabs. So this quick draw slab option is there. Not walls. This is elevation plan 3D. Slab 150. What is the difference between draw and quick draw? Quick draw. Yeah, quick draw is better because I have everything in my grids. We want to divide this slab or treat this as a single slab. Let's treat this as a single slab. If you divide this slab, then you have to take the rectangular area option. I think this way it is better. Treat this as a single slab. Ignore the secondary beams, though they will provide some support here. Okay. Yes. Let's move on to the next part. Can we copy the slab members from one floor to the another floors? Because the as far as the slab is concerned, since you're considering same, this is all similar. Okay, I think we can copy. So let's go below. Let's do the easy work. Okay, we'll go to select by properties, slab sections, slab 150. Everything will get selected. I think select close, so everything is selected. Let's go to 3D view and Ctrl plus R, replicate, and then story wise replication 3 4 5 not expired. Yeah, this should work. Done. And now for the multi level, we will draw a slab at the multi level plan. Okay, where is my slab option? Quick draw. I want quick draw slab. Yeah, this and this. 3D. So now we can say display undeformed shape, that the modeling is done, though the shear wall modeling is not done. Apart from the shear wall, the modeling is complete here. You can see in the extruded view itself. Let's check out extruded view. Here the modeling is done here, apart from the shear wall.